In this example, we've designed a hydrogen fuel cell electric propulsion system as a retrofit for a Britten-Norman Islander. And the first step in that propulsion system is a store of fuel or energy. So we store our fuel as hydrogen in gaseous form in high pressure tanks at 350 bar. That hydrogen fuel then flows through the hydrogen fuel distribution system, which is a set of valves and pipes and other devices, into the hydrogen fuel cell system itself, which you can see on the model here. Now the hydrogen fuel cell system, the area in blue on the model, is a combination of the fuel cell stacks, their associated balance of plant and their control systems. The fuel cell stacks within the hydrogen fuel cell system, that's where the electrochemical process takes place, which takes in oxygen from the outside air plus hydrogen from our fuel and combines it to generate an electrical power output. So one of the byproducts of the hydrogen fuel cell system, or one of the waste products, is heat. Hydrogen fuel cell systems are roughly as efficient as a conventional piston engine, but unlike a conventional piston engine, rather than the heat being rejected at high temperatures with exhaust gases, the hydrogen fuel cell system, that high level of heat, is generated at relatively low temperature compared to the outside air. So we need an advanced heat exchanger technology to deal with that waste heat with low mass and low drag. So in this pod here, in green on the model, contained within that pod is reaction engines, advanced heat exchanger technology based on microtubes in cylindrical arrangements, and that rejects that waste heat from the HFCS to the outside air, but in a very lightweight, so low mass piece of equipment, we're creating very little drag. So that's dealing with the waste heat from the hydrogen fuel cell system. Then in terms of the primary output from the HFCS, that's high voltage, high power, direct current electrical power for propulsion of the aircraft. And that's fed through a power distribution system, which is mounted around the rear of the nacelle. But that electricity is then fed into the electric propulsion unit, which is the three green assemblies towards the front of this model. And the electric propulsion unit comprises the electric motor itself and their associated inverter controllers. And the electric motor, or the EPU, converts that high voltage, high power electricity into shaft power in terms of providing the torque and the power to turn the shaft to drive the conventional propeller, which is conventional for a normal aeroplane, a three-bladed propeller, but in this case it operates or turns at a slightly lower RPM to the conventional aircraft at 2300 RPM rather than 2700 because that's better matched to the characteristics of the motor.